So this is the review video for organic chemistry. Again, we're not going to be doing much practice during the actual presentation, so we're just going to stick to the practice that on the review and on the practice sheets. So we'll just be looking for a quick summary of organic review. So this includes everything, all the naming conventions that we talked about. So it's easiest, I think, to condense it down since we're doing practice later. It's important first we have to understand that the new prefix system has to be with you at all times. If you haven't memorized it yet, you have to have this written down somewhere, otherwise well, you can't really name anything. After 5, there's familiarity, as in these are the things that we've seen before. Pent for 5, hex, hept, oct, non, and dec. But 4, 3, 2, 1 are kind of different. 1 being meth, from the methyl, that means there's 1 carbon. 2, eth, meaning 2 carbon. 3 is prop, and 4 is bute. Again, you don't have to memorize these, you just have to write them down on a piece of paper so that you can have them. And also importantly, this always corresponds to the number of carbon atoms. So if you have in any given molecule, at least for the purposes that we're talking about, in any given molecule, if you have 3 carbon atoms, that is a prop something. If you have 6 carbon atoms, that's a hex something, or something hex something. The main base of what you're naming comes from the number of carbon atoms in the molecule. So let's first talk about the 3 non-functional group classes. So this is just talking about how big this is. Okay. Alkanes, alkenes, and alkynes. So the general formula for an alkane we'll talk about later, but basically what an alkane means is they're all single bonds between atoms. So alkanes mean single bonds between all carbon atoms. Right, so this means that in your compound, in your chain, you have only carbons that are connected by single bonds. Again, carbons can have double bonds or triple bonds to other atoms, but in between the carbon atoms, there has to be only single bonds. That's the definition of an alkane. So if you count, let's do the 4 carbon. If you count the number of hydrogens, we know how to count this. This carbon has 1 bond, so it has to have 3 other hydrogens. If you want to draw it out, we'll draw maybe 1 out fully. 3 other bonds, so 3 other bonds are formed to hydrogen. This carbon has 2 bonds, and so it needs 2 bonds to hydrogens. This carbon has 2 bonds, so 2 bonds to hydrogen. This carbon has only 1 bond, so 3 bonds to hydrogen. Another way you can write this is just CH3, CH2, CH2, CH3. You just put the number of hydrogens, and you can basically know what this number is by looking at how many bonds carbon has and then subtracting that number from 4, because each carbon has to have 4 bonds. But you can see here that there's still only there's only single bonds between carbon atoms, and this gives the general formula for an alkane where you have N carbon. So N can be, again, in this case N is 4, so this is butane, right, because our 4 carbon was a bute, and then their ending is an ane for an alkane. So the ending is ane. So here you had 4 carbon atoms, so you will have more than double 4 hydrogen atoms. So in this case you'll have 10, but just more than double. So you have to, if you have more than 8, it's an alkane. Alkenes means that you can have multiple double bonds, but for our purposes we're just going to say double bond between carbon atoms. So what does that mean? So if you have, let's do 5 carbon atoms, if you have a double bond here you again just this carbon now has 1, 2, 3, so 1H. This also has 1H, H2, H3, and this is called pentene because the ending for an alkene is an ene ending, and basically you kind of have to also, well, we'll talk about the general formula first. This alkenes contain exactly double the number of hydrogen as carbon. So this is C5H10. I know this because it's an alkene, and alkenes, if the carbon has n carbons, the hydrogen will have exactly double the number of carbons. So there'll be 10 hydrogens for 5 carbons, 12 hydrogens for 6 carbons, etc. Important thing to note that you also have to specify where the double bond is in your carbon chain. So this would be pent2ene because the double bond is on the second carbon. This is the first carbon. Pent1ene would look like this. Where the double bond is right after the first carbon, so it's pent1ene. Whenever you add a functional group, with a couple of exceptions, you always have to specify which carbon the functional group is attached to. Alkynes is a triple bond between carbon atoms. So that is, let's do the 3 triple bond. This carbon already has 4 bonds, so it doesn't need any hydrogen. And this is CH3 because it has only 1 bond, so you have to add 3 more. The general formula, this is prop 1-ine, you can say. CnH2n-2, which means that if you have 3 carbon atoms, you have less than double, so less than 6 hydrogens, because you have a triple bond, so that kind of uses up the hydrogen. You don't need as many hydrogens, right? So you have less than double, so you have less than 6, in this case 4. And if you have C5, you'll have H8, which is again less than double of 5. So that's the general formula for an alkyne. Again, you just add how many carbon atoms, you put where the double bond for alkene and triple bond for alkynes are, and then you just add the ending ene for alkene and yne, Y-N-E, for alkynes. Right, now we're getting into the realm of functional groups. Now all functional groups are based off an alkane chain, so to speak. So we're only going to consider additional functional groups which already have alkanes with only single bonds between the carbon atoms. So you'll never have a double bond. You can have, obviously, but for the purposes of this course, you will never have a double bonded carbon with another function. So you'll never have double bond CCOH. So you see this is an alkene and an alcohol, and you'll never have that. For the purposes of this course. So only under alkanes we have a couple of different functional groups that we have to talk about. The first one, again, we're just going to be doing very brief things. So what is called? It's called an alcohol. Alcohol. Its ending is OL. What does the functional group look like? It looks like an OH attached to the carbon atom. So this bond here shows that this O is attached to the carbon atom, not minus OH. So for an example, you could do C, 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 and then attached to this carbon atom, there's an OH. You obviously have to fill in your hydrogens just as normal. Just count the number of bonds and subtract that from 4 to get number of hydrogens. This is but2-ol. Oh, sorry, butan-2-ol. Why is it butan? Why am I adding this an? Because that is my ANE for an alkane, because I started with butane. And then I have added a functional group. So instead of the E, I'm writing an OL for butan. And then I have to put 2 there because it's on the 1 second carbon. Right? So therefore, this is butan-2-ol. Again, the an extra bit comes from the fact that it's an alkane, because all of the functional groups are starting off with alkanes. And then I have to put the same number and where my functional group is, OL, for an alcohol. So that's the ending for an alcohol. The next functional group is a, let me just check if I'm doing this in order. Yeah, aldehyde, ketone. Okay, yeah. Where was I? Is an aldehyde. Ending is Al. What it looks like is a double bond. This is basically what the functional group looks like. If you have a carbon double bonded to an oxygen at the end or the beginning of a molecule, so basically at the edge of the molecule. So, like here, double bond, and so we have to add the H. Basically, if you have a double bond C double bond O at the edge of a molecule. So this is at the edge, so that H is necessary because this carbon only has 3 bonds, so it needs that one. Then you just fill in your hydrogens as usual. This is butan al. Again, because it's at the edge, it will always be the first carbon, so you kind of don't have to put the 1. If you put it, I won't mark you wrong, but it's not necessary. And again, butan al, because you recognize this functional group, that's an al ending. There's 4 carbons in total, so that's butan. Next functional group is a ketone, ending in ONE, and this contains C double bond O in the middle. So it doesn't have to be the exact middle, it's just not at the edge, middle of a molecule. Right, so this could be 1, 2, 3, double bond O, so this is prop and 2-one. Again, the AN is from the alkane propane with a 2-one, because the 1 second carbon has the double bond O, and that's not at the end, so it's a ketone. Right, so that was aldehyde, ketone. Next, we're going to do carboxylic acid. The ending is oic acid. And the functional group looks like C double bond O, but then an OH attached to it. So this is also at end. It has to be at the end. There's no way. 2, 3, 4, 5, or at the beginning. I mean, you can technically do this, and this is the end if you look at it from the other way. So this is fine. CH2, 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 CH3. This carbon, once you add the double bond OH, it has to be connected to another carbon. Or if it's just connected to one hydrogen, that means it's a 1 carbon carboxylic acid, so methanoic acid. Here I've drawn pentanoic acid because there's 5 carbons, so it's pent. There's only single bonds, so it's an an. And then I have a C double bond OH, so the ending is oic acid. Right, so that's a carboxylic acid. We're getting to the end of this video. I will continue the special reaction types and the special compounds another video. But the last one we're going to talk about, our basic functional groups, is an amine. The ending is very simple. It's just an amine. This is what it looks like. It's basically like an alcohol. Instead of an OH, there's an NH2 for an amine. So we can draw C. How many carbons do we want? I think we haven't done a 2 before. So we'll do C, C, NH2, H2, H3. Again, filling in the hydrogens based on how many bonds the carbon already has. This carbon had only 1 bond, so we had to put 3 hydrogens. This carbon had 2 bonds, 1, 2, so we put 2 hydrogens because they always have to add up to 4, the total hydrogens plus bonds. Well, hydrogens are bonds, so total bonds are 4. But yeah, so this would be eth because there's 2 carbons, an because there's single bonds between the carbons, and the ending of amine because there's an NH2. Again, you can add 1 amine because this is the first carbon, this is the second carbon. If it's at the end, if functional groups are located at the end, they always have a end or beginning. I mean, they always have a value of 1, so you don't really have to write that. It's just if they occur somewhere else, you got to specify where they're occurring. So that only applies to, like, if you have pent, then you say, oh, pent and 2-amine, or pent and 3-amine, etc. So the last one we'll talk about are haloalkanes. So this could be, really, there's no, we'll just call them haloalkanes because that's their name. The suffix is not an ending now, but it's a prefix instead. So you could have chloro for Cl, bromo for Br, iodo for I, and fluoro for F. So it depends on what halogen you are adding, but chloro is Cl, bromo is Br, iodo is I, and fluoro is F. For example, if you have this is hexane, but again, this is a prefix, right? So you're adding 3-chlorohexane. Well, the halogens, for some reason, they don't become hexane chloro. They become chlorohexane. So these things don't come after. We've been putting these after the prop or whatever, bute or pent or eth, but now we're gonna put these things before. So this is 3-chlorohexane. If instead of that 3-chloro, let's erase that, there had been something like this would be 2-iodohexane, right? Because there's an iodo group, it's on the second carbon, and it's 6 carbons, so it's a hexane, so 2-iodohexane is what that's called. So again, we'll come across a lot of these in practice. This is a brief overview of all of them. We have one more video with special types, polarity, and reactions coming up. So we'll do that, and then we'll get to the practice.